Hello everybody. We're going to do multi-integration again. This time we use a little bit more complex question, the volume of ellipsoid. Okay. Now I want you to look at the previous video because it talks about how to set the boundary of multi-integration. And previous one was easy. Quick review. It was x plus y equals 1, the boundary, and x equals 0, y equals 0, and we calculate the volume above this triangle. Okay, this time we are talking about ellipsoid. So we take, say, xy area, and this is going to be the boundary. Okay, so in this case, say this is x and this is y and this is z. The height is z, and equation of ellipsoid is going to be x square a square plus y square b square plus g square c square equals 1, right? And z is the height. So the height function is going to be c square root let's see, 1 minus x square a square plus minus b square, right? Okay, so this is the height function. So integral to calculate the volume is going to be, this is, say, all symmetric. We are calculating only 1/8 of the volume. So whole ellipsoid, you have to multiply by 8. And x is 0 to a, right? And we calculate y. And in the y is on the xy plane, z is 0. So from here, y is going to be b 1 minus x square a square, right? So this is the boundary. Say boundary is u. So 0 to u and z dx dy. Okay, so we have to calculate. Once we calculate this integral, we get the ellipsoid volume, entire volume, right? And the hope is we come up with the well-known formula, 4 over 3 pi a b c. Okay, if you come up with this, then you are successful. Okay, so remaining is just a skill of taking an integral of the z. And z here, since this is u, is kind of u square over b, right? Is that right? So c u square over b square minus y square b square is going to be c over b u square minus y square, and u doesn't have a y, so this is the integral you have to calculate. Okay, and this can be done. Integral of this. Well, it takes a couple pages, so we cheat. Okay, you can look up the back of the calculus textbook or internet, whatever. This can be done, and the result is kind of complicated. Result is y u square minus y square 2 plus u square y over u. So this part you can cheat. Look up whatever. This integration can be done, but the result come into 2. So what we need is 0 to u, right? And if you put u, it's 0. If you put 0, this is 0. So this will disappear. So it's going to be only u square t sine inverse sine of 101. And what is this? This is 2 pi, right? So equals u square pi. It's getting cleaner. So volume is going to be 8 0a u square. We put the u. Let's see. B square 1 over x square a square, right? Is that right? So actually, don't forget this. We got C, BC. Getting closer to this one, right? Okay, so we have to deal with this 0a 1 minus x square over s dx. And this is straightforward, right? It's gonna be x minus 3a square x cube 0a. And this a and 0 is going to be again volume is 8 b c 0a. It's already took integral, so a minus a cube 3a and 0 and square. So this is gonna be don't forget this and this dropping all over pi. Don't forget the pi, and you have 2 pi. Let's see, this is gonna be A, right? This part, and 8 B C, and oh, here's a 2. Don't forget this pi. So we forgot. We drop out some constant. It's supposed to be 4/3. Let's see where we drop it. Oh, okay. This 2. And this is wrong. So this we need a 2. Anywhere else we dropped 2. You can go through this. This constant is end up with A, B, C. That's the answer. Okay. So it's a little messy. Just write it whole things carefully, and don't drop out any constant. So we get this ellipsoid volume. So this is the more complicated case of the previous video, multi-integral, how to set the boundary, and very good example of setting boundary. It's ellipsis boundary and calculating ellipsoid volume. Okay, so if you like this video series, more challenging calculus drills coming up, please subscribe so that you don't miss it.